Hi, in this video, I'm going to introduce you to routing, specifically the Cisco IPv4 routing table. Let's take a look. Okay, so first of all, remember what routing is all about as far as the router's perspective. Is the router receives an IP packet encapsulated in a data link frame, or unencapsulates it. And what it does is it's all about examining the destination IP address and looking that up in its routing table to see where is it going to forward it next. Okay. And you'll learn more about routing in later videos and that, but let's kind of get past all this. You've seen this animation in my other videos. Okay, there we go. All right, so let's take a look at a Cisco IOS routing table. All right, so the command to examine a Cisco IOS routing, IPv4 routing table specifically, is the show IP route command. So here we're looking at the routing table on router R1. Now a routing table is going to show the networks that this router knows about, and two types of networks. Those that are directly connected to. A directly connected network means the router has an IP address on an interface. Let me circle those. There we go, and get this whole thing. So this router has 3 interfaces, and each interface has been configured with an IPv4 address and a subnet mask, which tells the router that it belongs to 3 networks. That's really no different than the PC. The computer, PC1, has an IPv4 address and subnet mask and tells it what network it belongs to, right? But computers, end user devices, usually belong to just one network. The difference is the router will belong usually to multiple directly connected networks. And not only that, but it will also know about remote networks. That's usually the idea of why we need a router, is to learn about these remote networks. And it can learn about remote networks that it does not have a direct connection to. It can learn about them either statically, and we'll take a look at this stuff later, but a static route is where we have to manually have to tell the router what the remote network address is. And that's all we need is the network address and its subnet mask. And what is the next hop address to get there? The other way that routers can learn about remote networks is dynamically, using dynamic routing protocols like EIGRP, OSPF, and ISIS, for example, where the routers actually, using the same dynamic routing protocol, will exchange information about the networks that they know about and eventually learn about all the remote networks that all the routers are sharing in the same, what we call, routing domain. All right, so let's take a look at how to look at this routing table, at least just the basics of it. Okay, so directly connected routes. Okay, so I mentioned that a directly connected route is a network that this router is directly connected to. Now you'll notice router R1 actually has 3 directly connected networks, 3 interfaces. It has 3 interfaces, each with a different IPv4 subnet or network address. Okay. So we have one here, and one here. So let's take a look at this one here, the gigabit 00. So if you notice in the routing table, here are the 3. 1 group, 2 group, 3 groups. I'll talk about the C and the L. These codes I'm going to show here in a moment, but the C means directly connected, and the L means it's local address. What is the actual address? So let's take a look at one of the directly connected ones, this one right here, which is right here. So first, the status code. I mentioned C means the the connected network. What network am I connected to? And the L just means what's my actual IPv4 address in this case of that interface. So if we look here, we can see that this first part is the network address in the connected, and actually the actual IPv4 address itself. The /32, let's not worry about that right now. It's known as a host mask, but it is just that it's just telling the router, this is my address. But the network I belong to is 192.168.10.0/24. I am directly connected, and it also is directly connected here. And the actual interface is the gigabit 00 interface, as we can see here. Okay. Routers can't do anything unless they already unless they're connected to at least one directly connected network. It has to know about its own networks before it can learn about any other networks. All right. Okay, let's see. I actually had an animation there, but I don't think I need it. All right. Let's go to the next one. Okay, in this case, a dynamic route. So let's take a look. In this case, we're going to look on R1, and it has actually, let me kind of go right here. So on R1, and we're going to look at this network in the routing table. And the network we're actually looking at is 10.1.1.0, which is this remote network. So this is a network that R1 does not have an interface directly connected to. But it's actually learned about this network. Let me go to the next. There we go. It's actually, let's take a look at this in a little bit more detail here. Okay, so we're just looking at this information right here. So how did it learn about this network? Well, it learned it using a dynamic routing protocol called EIGRP. Now, the D actually doesn't stand for dynamic. It actually stands for the routing protocol. D for EIGRP. How'd they get that? Oh, long story. But D actually stands for dual, D-U-A-L, the algorithm used by EIGRP. Doesn't use an E because that was used by another routing protocol. Not important, but this is how it learned about the route, in this case, EIGRP. Here's the remote network. Okay, so there's the network that it learned about. Okay, these next times, not real important yet, but we'll talk a little bit about them. This 90 is actually, and you follow it here. This is what we're doing here. Here, for example, the 90. That is known as the administrative distance. Okay, not important at this point. We'll talk more about it in later videos, but it's just associated with kind of a ranking of the source of the information, in this case, EIGRP. This next value here, this is the metric. So EIGRP uses this combination of lowest bandwidth and cumulative delays. Don't worry about that, what that is, but how far away is this network? So that's what the metric tells us. This via IP address is the next hop address. This is a timer that tells the router, how long have I known about this route? And this gets refreshed continuously by the routing protocol, and depends on the routing protocol. Don't worry about it too much right now. This here is the exit interface. So you'll see serial 000. This is the exit interface, the interface it's going to go out of. This is actually how the router knows what type of data link header and trailer to send it out of. What is the encapsulation of serial 000? Is it PPP, point-to-point protocol? Then that's the kind of data link header trailer it's going to go into. So this is kind of looking at the an example of a dynamic route or a route learned dynamically, in this case, a routing protocol called EIGRP, Enhanced Interior Gateway Protocol. Whew, so many acronyms in this business. But we'll learn about all that later. But at least you've seen that this is how you can recognize a remote route in the routing table. All right. Remember those codes I talked about? Remember those codes that are down here? Well, here they are. I just hadn't shown them in the other routing tables just to make things a little bit cleaner. But they're always shown when you do the show IP route. Again, we're looking at an IPv4 routing table. Let's take a look at some of those codes. There's our C for directly connected, and you'll see it along with an L, meaning the local interface IP address. Where's that D for EIGRP? All right, it is right. Well, let's see, where am I looking? Here it is. Okay, D for EIGRP. Again, why wasn't E used? Because that was used by an older protocol called Exterior Gateway Protocol. That's not used anymore. Okay, but you can see some of the other ways. If we had a static route, it'd have an S in it. It was learned by a routing protocol RIP. It would have an R in it. All right. So this all says, what are these codes right? Oh, what happened there? Okay, those codes were, oh gosh, okay, I guess I can't go off the screen there. Okay, but those codes right there. All right, well, we're at the end of this video, so, you know. All right, so I hope this helps you begin to see what the routing table is all about. And again, it's all about showing routes either dynamically or directly configured, or actually both. Definitely you're going to see directly connected networks, okay? So you're always going to see these directly connected, at least one directly connected networks. And then as far as remote networks, you're going to see either dynamic, static, or a combination of both. And that tells the router about networks that it is not directly connected to. It does not have a direct connection to. All right. So I hope this demystifies at least a little bit of the IPv4 routing table. I know there's a lot more to it, especially IPv4, but I think this is a good first step to help you understand it.